All right, hey everybody, Mr. Withers here. We're going to chat quickly today about 4 special segments and points within triangles, and then you'll have a little time to practice these. So the first thing that we're going to talk about is a perpendicular bisector. So we know that a bisector splits the base of a triangle in half. Now, this bisector doesn't always go straight to the point. So in this situation, you can see that bisector actually does not go to the vertex of the triangle, but it cuts my base in half, or bisects it, and is perpendicular. So this is what we would call a perpendicular bisector. Perpendicular, I'll abbreviate that. Bisector. Now, perpendicular bisectors in a triangle have a special property if we draw all of the perpendicular bisectors of that triangle. So for example, if we cut a different side of our triangle in half, perpendicular, oops, that's not quite perfect, sorry, and we cut another side of our triangle in half, perpendicular. So I'm cutting this in half at a perpendicular, I'm cutting this in half at a perpendicular. You can see there's a spot where all 3 of these perpendicular bisectors meet. And this is a special point in a triangle. This is called the circumcenter. Circumcenter. The circumcenter is where the perpendicular bisectors of a triangle meet. Where the perpendicular bisectors of a triangle meet. Now, what's interesting about this, if we were to go to that point in our triangle, it is actually the exact same distance from each vertex. These lines aren't perfect, sorry. But the circumcenter, where those perpendicular bisectors meet, is equidistant from each vertex. Equidistant from each vertex. So if you were to draw 3 perpendicular bisectors and find the spot where they meet, you would have a point that is exactly the same distance from each corner of your triangle, and that is called the circumcenter. All right, if you need to pause and get this copied down, feel free to. Otherwise, we're going to move on to special property number 2. Let me get another triangle drawn here. So our next segment we're going to talk about is an angle bisector. And we know that an angle bisector cuts the angle in half into 2 equal pieces. This does not end up always perpendicular. It does not end up always bisecting our opposite side. All that we know is that this bisects the angles. This is an angle bisector. The cool thing about angle bisectors, if we connect all of them, so I'm going to cut this angle in half, and I'm going to cut this angle in half, pretty close. We have cut each of these into 2 equal angles, and you can see that those angle bisectors also all meet up at a point. This special point is called the incenter. Incenter. The incenter does have a special property as well. The incenter is the exact same, well, I guess we should define it first, sorry. We're going to say where angle bisectors meet. Where the angle bisectors ran out of room there, sorry, of a triangle meet. And the cool thing about in-center is it is equidistant from each side of the triangle. Each side of the triangle. So this point is exactly the same distance from each side of our triangle. Apologies that that doesn't look perfect, but you know, Mr. Withers, I'm not a robot, doing my best here. So the in-center, where those angle bisectors meet, is the exact same distance from each side of the triangle. That is in-center. If you need to pause there to catch up on notes, please do so, and we will move on. Our next line segment we're going to talk about is the median. Now, the median is sharing some of our perpendicular bisector properties, but it does not necessarily always end up perpendicular. The median goes from the vertex to the midpoint of the opposite side. So you can see in this situation, it is not perpendicular, but it will bisect the opposite side. So it's going to go to that midpoint of the opposite side. So again, this is called the median. And the median goes from the vertex to the midpoint of the opposite side. And like we've seen with our other two examples, this has a special property as well. So if I draw, I can make that better. If I draw from the vertex to the midpoint and the vertex to the midpoint, so I draw three medians, you can see they all meet at one spot. And that spot, this is probably my favorite name, is called the centroid. Centroid. And the centroid of a triangle is where the medians of a triangle meet. And the cool thing about the centroid, anytime you have a centroid in any triangle, it is exactly 2/3 of the distance from the vertex to the midpoint. So if you look at that centroid, it is 2/3 of the distance of that median. It is 2/3 of the distance of that median. And it is 2/3 of the distance of that median. And those notes don't necessarily represent what I'm trying to say. So let's pretend that this was 4. This would be 2. So 4 out of 6 total distance, 2/3 of that distance. Maybe this would be 6 and 9. Okay, nice. So 6 out of the possible, not 9, sorry, 3. 6 out of the possible 9 units there between the vertex and the midpoint, 2/3 of the way, is that centroid. Hopefully that makes some sense. So again, the centroid falls exactly 2/3 of the way between the vertex and that midpoint on the opposite side. So that median gets cut into a 2/3 piece and a 1/3 piece. Another way you could think about that would be that the longer portion is exactly double the shorter portion because it's 2/3 and 1/3. So that is the centroid. Pause there if you need to catch up, and we have one more. So get a new triangle built here. Our last special property is the altitude. The altitude. And the altitude goes from the vertex in a directly perpendicular line to the base, or the opposite side. So altitude from the vertex to the opposite side, 90 degrees perpendicular. So you can see this does not bisect at all, but it just goes from vertex to its opposite side in perpendicular fashion. We do have a place where these meet, and I'll try to draw this one here. This one's going to happen pretty high up, I think. This one will be like that. Yeah, so this happens pretty high up here. Where these altitudes meet is called the orthocenter. Orthocenter. I know some of you are like, wait, that's where I get my braces, at the orthocenter. No, this is orthocenter. This is where the altitude, sorry, I think my iPad glitched out there. This is where the altitudes of a triangle meet. And you'll love this. There is nothing special about orthocenter other than they just wanted to have a name for where the altitudes met up. So there's nothing about that point that really helps us in any way other than just if you connect all the altitudes at a spot, they wanted to have something to call it, so they named it the orthocenter. So that is what we call it, but there's nothing really that benefits us about that. It is just the space or the point where the altitudes meet. All right, so those are our 4 special properties today. We have a name for those. They are called points of concurrency. Points of concurrency. If you think about concurrent, kind of meaning where things meet up, makes sense. Points of concurrency, and just as a recap, we have the circumcenter, we have the incenter, we have the centroid, Mr. Withers' favorite, and we have the orthocenter. These are our points of concurrency in a triangle. If you're looking for a table to help remind you of this, pretty much everything I wrote down in these last 4 examples can be found in your textbooks on page 339. There's a nice, neat table that talks about exactly what we just talked about. So if you need a little recap and you don't feel like listening to me talk about it again and rewinding the video, you can go to the textbook. Page 339 talks about these points of concurrency. And then in the pages right before it, 338 and 337, you can see some examples of problems worked out. So as you saw on Canvas today, you have just a couple practice problem opportunities. I believe they start on page 340. So if you go in the textbook to page 340, and anything between really number 5 and number 20 would be good practice. You can skip around, you can pick which ones you want to do. This is not homework, it's Friday, but just an opportunity to practice, and then we're going to continue with more of this work next week. So hopefully this made some sense today. If you have questions, just bring those Monday, and I'm happy to chat with you about them. Points of concurrency. Get some practice in for the rest of your time today, and that'll be it. Have a great weekend. All right, bye everybody.